Hello, welcome to today's lesson on fractions. To start, we're just going to recap what a fraction is. So a fraction is just a part of a whole number where each part has to be equal, so all the parts have to be the same size. The top number in a fraction is called the numerator, and the bottom number in the fraction is called the denominator. So if we have a little look at this fraction below, you can see there's a 3 on the top and a 4 on the bottom. We read this fraction as 3/4, and you can see in the diagram here, this is how 3/4 could be represented. So 3 parts are shaded and there are 4 parts altogether. The numerator, the top number, represents the number of parts you have. So for example, in this question, the 3 parts that are in green. And then the denominator represents the total number of parts altogether. So altogether in this shape there are 4 parts. So now we're going to have a little look at simplifying fractions. Firstly, this keyword simplify just means to make something simpler or easier to understand. So if you think of a fraction, if we want to try and make it easier to understand, we're going to try and make the numbers in it a little bit smaller, and that's what simplifying is. So to simplify a fraction, we need to look to see if a number bigger than 1 will fit into the numerator and the denominator. Okay, so it has to fit into both of the numbers in the fraction. If it does, you want to divide. This is going to make these numbers smaller. So whatever number can fit into the numerator and the denominator, we want to divide both of these numbers by the number that will fit into it. You can keep doing this over and over and over again until the only number that will fit into both of the numbers in the fraction is 1. So it can't go any smaller. So we're going to have a go of a few. So write the following fractions in their simplest form. This is another way of just saying simplify the fraction. Okay, you can almost see that word simple in simplest form. So you want to shrink it down until the numbers are smaller on the top and the bottom, but it means the same thing. So first one, 12 over 18. So we need to think of a number that will fit into 12 and into 18. Now there are a few numbers that fit into both of these. 2 fits into 12 and 18, 3 will fit into 12 and 18, and so will 6. It's easier if you pick the highest number because it means you'll have to do less steps. So if we, like we said, 6 fits into 12 and 18, so if we divide both numbers by 6, okay, 12 divided by 6 gives us 2, and 18 divided by 6 gives us 3. And if we look at this fraction now, the only numbers that fit into 2 and 3 are 1, so it is in its simplest form. Just because some people might not realise that 6 goes in, if you started by dividing by 2, for example, so if you saw that 2 went into both these numbers, if you halved it, if you divided both of these numbers by 2, 2 goes into 12 6 times, and 2 goes into 18 9 times. But if you have a look at that fraction now, it's not the same as the one we had at the beginning. Okay, 6 over 9 isn't in its simplest form because there is another number that goes into 6 and 9. So 3 now fits into 6 and 9, so you would have to do a second step, divide both of these numbers by 3. 3 fits into 6 twice, and 3 fits into 9 3 times. So now you can see we have the same answer. So you can choose smaller numbers to simplify a fraction, but you're going to have to simplify the fraction a number of times. So it's easier to try and pick the highest number that go into both of these to save yourself lots of steps. For question 2 then, 14 over 49. So we need to think of a number that fits into 14 and 49. Well, if we think of 14, 2 times 7 is 14. So if we think of that 49 now, 2 won't fit into 49, but 7 does. So 7 is a common factor. 7 will fit into 14 and 49. So if we divide by 7 on this fraction, 14 divided by 7 gives us 2. And 49 divided by 7, remember 7 sevens are 49, so 49 divided by 7 is 7. If we have a look at this fraction now, it will not simplify any further because the only number that fits into 2 and 7 is 1. Last example then on this. So 54 over 72. So we need to try and think of the highest number that we can think of that fits into 54 and 72. Okay, 72, some people might think of 8 times 9. Okay, so if we look at that 54, you might realise that 9 will fit into 54 as well. Okay, so 9 is quite a high number that will fit into both of these numbers. So if we divide by 9, 54 divided by 9 gives us 6, and 72 divided by 9 gives us 8. Okay, so we've now got 6/8 as our fraction. So we need to have a little look at this fraction again. Does any number fit into 6 and 8? Yes, 2 will fit into both. So we want to now divide by 2, so we do have to do a second step in this, even though 9 was quite a big number to divide by. So now we need to half this 6 over 8. So 6 divided by 2 is 3, and 8 divided by 2 is 4. So now we've got the fraction of 3/4, and nothing will fit into 3 and 4 apart from 1, so it's in its simplest form. So just make sure that that final fraction can't be simplified down any further than what you've got. Last example on simplifying then. So what fraction of the shape is shaded? Give your answer in its simplest form. So you're given this shape here, you can see it's split into lots of little triangles. So we need to try and write the fraction down first. So if we remember, we want the fraction of the shape that is shaded. So count the amount of shaded parts first. So you've got 1, 2, 3, 4, 5, 6. So that's going to be your numerator in the fraction. And remember, the denominator is the total amount of parts. So the total amount of small triangles. So if we count them, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're going to have 16 on the bottom. So our fraction to start is 6 over 16. We now need to look to simplify, as it asks us to give it in its simplest form. So a number that fits into 6 and 16. Well, these are both even, so we could just divide by 2. So if we divide by 2, how many 2's go into 6? 3. And how many 2's go into 16? 8. And if we have a look at this fraction now, 3, odd number, the only numbers that fit into 3 are 1 and 3. So we cannot simplify that any further, as 3 doesn't fit into 8. Next part of the lesson now is going to be equivalent fractions. So another key word here, so this equivalent just means equal to, or that it has the same value. Okay, so equivalent fractions are fractions that are all equal to each other, but they can be written in lots of different ways. So for example, these pictures below, you can see they're all different types of halves. So the first one, you can see it is only split into 2 parts, but only one of them is shaded, so it's a half. The second one is actually split into 4 parts, that's why it's a quarter, but 2 are shaded. It's just another way of writing a half. And the same for the others. So you can see this last picture, it's split into 8 parts altogether. It's an eighth, but 4 are shaded, so 4/8 is another way of writing a half. There is an infinite number of equivalent fractions, as it would depend on how many parts the whole has been divided into. So for example, another way of writing a half is if you had 100 parts altogether, to have a half of them, you'd need 50 of them shaded. So 50 over 100 is another example of an equivalent fraction of a half. But like we said, there is an infinite number of them. So filling in the missing gaps of these following equivalent fractions. So remember that equals means that the 3/5 is equal to something over 20. So you can try and picture it, but really, whatever you've done to a number on the bottom, you need to make sure you do that to the top, and vice versa. So for example, this 5 here has changed to a 20, and you want to look to see what's happened. So like when we were simplifying, you had to divide both numbers, the numerator and the denominator, by the same thing. It's the same here now, so this time we're actually making this number on the bottom bigger. So 5 to 20, what has happened? And you have to times or divide. So 5 times 4 gives us 20. So because you've times the bottom number, the denominator, by 4, that means you are going to have to times the numerator by 4 as well, because you have to keep this question equal. So 3 times 4 gives us 12. So you put a 12 in the gap. So 3/5 is equivalent to 12 over 20. Second one then, so we're given 5/7 equals to 30 over something. So we've got both of our numerators this time, and we've got a gap on our denominator. So 5 has changed to 30. So you need to think, what has it been times by? How many times has it been made bigger? So 5 times 6 gives us 30. So because the top number has been multiplied by 6, we need to multiply the denominator by 6 too. So 7 times 6 gives us 42. So our final answer is 30 over 42. So remember, whatever you do to the numerators, you need to do to the denominators, and vice versa. Number 3 then, you can see you've got a missing gap in your first fraction here. So you've got 6 over something equals 18 over 27. So again, first of all, we've got both of our numerators here. Okay, so 6 times what has given us 18? So 6 times 3 has given us 18. And then you need to think on the bottom now, something times 3 is 27. So this time we're actually going backwards. So you actually want to find out how many 3's has fit into 27. So you are dividing, because you're going back to the first fraction given. So 27 divided by 3 gives us 9. And that does look sensible, because 6/9 will equal 18 over 27. If you did 27 times 3 here, you'd get a really big answer of 81, and your fraction wouldn't look sensible. So think about what you're doing on both. Last one then. So something over 7 equals 32 over 56. So both of our denominators are given to us, so we need to compare these. So 7 times what has given us 56? Well, 7 times 8 is 56. So then we've got something times 8 is 32. So this time we've got the 32 and we want to work backwards. So we want to do 32 divided by 8. Well, 8 fits into 32 4 times. So just concentrate where your gap is, depending on whether you're timesing or dividing, and think, does your number need to go bigger or does it need to go smaller, and does my final answer look sensible? 2 GCSE questions then. So it says, draw a circle around each of the following fractions which is equal to a half. So you can see we're looking at equal to, which is an equivalent. So you need to look to see if each fraction is equal to a half, equivalent to a half. So a different way of writing down a half. So this first number, you don't need to go through each fraction separately, and if it's a half, draw a circle around it. So this first fraction, 3/9. We're actually going to simplify these fractions to see if it gives us 1 over 2 at the end. So 3/9, the only number that goes into 3 and 9 is 3. So if we divide them both by 3, we get 1/3. That's not a half, so don't circle it. 6 over 12, you can see 6 fits into both there. 6 goes into 6 once, and 6 goes into 12 twice, which is a half, so 6 over 12 is a half, so we can circle. 2/8 simplifies down, so 2 goes into both, so it goes into 2 once, and 8 4 times, not a half. 20 over 30, you can see 10 fits into them, so if we divide by 10, we get 2 over 3, not a half. 15 over 30, you can see that top number doubled is 30. So if we divide by 15, we get 1 over 2, so this one is a half. And the last one, 10 over 25, 5 fits into both. It fits into 10 twice, and it fits into 25 5 times, not a half. So you need to work through the fractions given, simplify them down to check if they give the fraction in the question. Question 6 then, so draw a circle around each of the following fractions which is not equal to a third. So a lot of these fractions are going to be equal to a third, but we want to circle the fractions that are not equal. So if we look at the first one, 5 over 15, 5 fits into both, 5 fits into 5 once, and 5 fits into 15 3 times. Remember, we were dividing by 5. So that one gives us a third. Remember, it's asked us to circle the ones that are not equal to, so don't circle it. This next one, 3 over 30. 3 fits into both of these numbers. 3 goes into 3 once, and 3 goes into 30 10 times. So you get 1/10, that is not equal to a third, so we can circle that fraction. 4/12, 4 goes into both of these numbers. So if we divide by 4, 4 goes into 4 once, and 4 goes into 12 3 times. You can see it is equal to a third. 2/6, 2 goes into both of these numbers. So if we divide by 2, 2 goes into 2 once, and 2 goes into 6 3 times. Again, a third, do not circle it. And last one, 3/6, 3 fits into both of these numbers. So 3 goes into 3 once, and 3 goes into 6 twice. This gives you a half, not a third, so we can circle it. Just as a little tip on these GCSE questions, the amount of marks that it gives you is sometimes a hint to the amount of fractions that you need to circle. So keep an eye on the marks, because sometimes it's a nice hint that you need to be circling more than one. Don't stop once you've found one answer.